Alright class, so this lesson is going to be about end behavior of a function. Alright, so we have here, when we're looking at the end behavior function, we're looking at the behavior of the graph of f of x as x approaches positive infinity and x approaches negative infinity. Okay, so let me just quickly talk about how do we notate x approaches positive infinity and x approaches negative. For positive infinity, we're going to write as x approaches, so we put a little arrow, positive infinity, just put the infinity symbol, comma, f of x approaches, and then this is where we're going to write our answer. Okay, so right now we're not really looking at a function. I'm just showing you how do we write this answer. And then for negative infinity, as x approaches negative infinity, f of x approaches what? And then we'll talk about that. Just keep that in mind, and then we're gonna that's how we write the statement here, as x approaches positive or negative infinity. Okay. All right, so now looking at the examples we have here, there are 4 types of end behavior, and we're going to look at all 4 types here. Okay, so what we have here is an end behavior where your function, it starts up at the top and then it comes down and then it goes back up. Okay, now just be mindful that depending on your function, we could have different things that happen here. For example, it doesn't have to be a perfect U. It could do something big, can go up and down, but then eventually it's going to end up going back up. Okay, when we have that, we call that an even function. Whenever we have them both going the same direction, we call it an even function. And this is a positive function because they both are going up. And here's an example of an even positive function. F of x is 2x squared plus 4. This is an even function because when I look at the degree is the exponent here. We have an even number. The degree, this has a degree of 2. So this is and 2 is an even number. And how is this positive? We look at the leading coefficient. Remember, the coefficient is a number in front of the x. So here, my number in front of the x is 2. My leading coefficient is 2. And 2 is positive. We don't care if it's odd or even, but we look at if there's a negative sign or not. Since this is a positive number, we call this a positive function. Okay, so this is how I would write my answer. We would say as x approaches negative infinity, so on the left side, f of x, or your y, remember this is your y-axis, and remember y, we can write that as f of x. It's the same thing. F of x approaches positive infinity because it's going up. So you see all the numbers are going up to positive, it's just going to positive infinity. And then on the right side, as x approaches positive infinity, I'm talking about all of these positive numbers, my f of x is going to positive infinity. It's going up, so we have to say positive infinity because of all the positive numbers. Okay, alright, so that's one type of end behavior. Another type of end behavior we have are even and negative end functions. So an even function will have the same end behavior, but since it's negative, whatever it's doing in the middle, that's fine. It's going to both go down. Okay, so they have the same end behavior and they both are pointing down. And here's an example of an even negative. This is an even function because my degree is 4. So 4 is an even number. And then this is a negative because my leading coefficient is negative 3. So this is a degree of 4. And this is a negative leading coefficient. So my leading coefficient is at negative 3. I just put LC for leading coefficient. Okay? Since this is a negative number, I don't care that it's 3, but I do care that it's negative. It's going to point down. So if I were to write the end behavior for this, and this is how the answer will look like. So this column that I have here is what you need to give for your answer. As x approaches negative infinity on the left side, f of x approaches negative infinity, and as x approaches positive infinity, f of x, oh, I'm sorry, I did this wrong. This is, as x approaches negative infinity on the left side of my graph is going down, so this has to be negative infinity. And as x approaches positive on my right side of the graph, you see how my graph is going down? We call this, and we can say this is also negative infinity, okay? The third type of end behavior that we have is an odd positive. The odd tells me that they have different end behaviors, and the positive tells me that it's eventually going up. So something like this. It's going to start from the bottom, and then it's going to go up top. Okay? And here's an example of a odd positive function. Odd because my exponent is 3, so this is a degree of 3, and 3 is an odd number, and this is positive because my leading coefficient here is 1, because the number in front here is 1, and it's just a positive number, it doesn't have a negative symbol. Okay, so if I were to write this answer as x approaches negative infinity on the left side, you see all my x out negative here. What is my function doing at f? My f of x is going towards negative infinity. So that's how I write this. And then as x approaches positive infinity, my f of x is going to positive infinity. Finally, the last one, my last type of end behavior. So again, we only have 4 types of end behaviors for functions. We have an odd negative. What that means is we have 2 different end behaviors, so they're going to be at opposite directions. And then, but since it's negative, it's going to eventually go down like this. Okay? So it's going to start at the top and then go down. So how do we write that? As x approaches negative infinity, we always start with the left side. F of x goes to, on the left side, what is your function doing? It's going up. So we say positive infinity. And as x approaches positive infinity, on the right side, my f of x is approaching negative infinity. Okay? So if we were to kind of take just kind of look at it and all together, you see there's 4 types of end behavior. We have your even. Let me erase all this, because I think you understand where I got this. Okay. We have even. So even functions, they have the same end behavior. And then positive is going to go up, negative is going to go down. We have your odd are going to have 2 different end behaviors. One comes, they have opposite direction. And this is positive, so eventually going up, and negative is eventually going down. Okay? Your job is to remember how to write this answer. All right, let's look at some examples that we have. Oops, sorry. This is a lesson that I already did. Okay. All right. Okay. So describe the end behavior of a function. So I'm going to look at the degree. The degree is the highest power. This has a degree of 3, so we know that 3 is an odd number. So this is an odd, and the number in the front is negative. So this is odd, negative. If I were to draw this out without, using my graphing calculator, I can just kind of, since I'm talking about the end behavior, I'm not worried about in the middle, just what's going on towards infinity. We can say this as odd, so we have two different end behaviors. Either it's going to go from bottom to top or top to bottom. Since this is negative, I spelled negative wrong, but since this is negative, it's going to have to start from the top and then eventually go down. Okay? So to write my answer to this, I have to say as x approaches negative infinity on my left side, let me just write that here for you. On my left side, what is my function doing? My f of x is going to, on my left side, it's going up. So I have to say positive infinity. And then as x approaches positive infinity, to you that means on my right side, what is my f of x doing? It's going to negative infinity. On the right side of my graph, it's going down. So we say negative infinity. Okay. I'm just going to go through some of these multiple choice questions, and then let me know when you see me in class if you have any questions. This one, I have a multiple choice. I just have to pick my answer. So I know that this is going to be an even function and it's a positive, so it's going to look something like this. It's an even, so they're going to have the same end behavior and it's going to go up. I do wanted to show you that if you can't remember the rules for the end behavior, you always have your graphing calculator and you can graph the function and look at the end behavior and then find your answer that way, and that's totally fine with me. So you got to go to y equals 2x squared, but I know if you're watching this at home, you probably don't have a calculator with you, so that's alright, you can just follow along on mine, plus 16. We're going to graph it. Alright, so like I said, they both have the same end behavior. Now again, I'm not worried about what the graph is doing in the middle. I'm just worried about the end behavior. So it looks something like this. So they both are pointing up. So on my left side, as x approaches negative infinity, my graph is going up top. So this looks good. And then on my right side, as x approaches positive infinity, my f of x is also going up. So they both work. Okay. And then number 5, this is an odd function, so I know I have different end behavior. So these are same end behavior. This looks like an even function. This looks like an even function. So these two are odd because they have different end behaviors. Now, let's see, which one do I choose? So since this is a negative, as my x approaches negative infinity, so it's going to look something like this, right? As x approaches negative infinity, on my left side, my f of x is going up. Yep, that's true. And then as x approaches positive infinity on the right side, my f of x is going down. That's true. So the answer is C. Okay, I have more examples in here that you can try, and just let me know if you have any questions and I can check your work for you. Okay?